Okay, so here is the lesson on second order differential equations. Now, I know I've said this about a lot of topics, but this is one of my favourite topics. And if you go into university and if you study a maths-based degree, there's a full module based on second order differential equations. Okay, so first of all, they are really easy to spot. So as you can see here, you've got a second derivative here, and then you've got your first derivative, and then you've got a function of y equals f of x. Okay, so a, b, and c are just going to be like constants. Okay, feel free to pause the screen and copy this page into your notes jotters. I would just try to save some time, as always, just by copying it in. Okay, right, so whenever you see a second order differential equation, the reason why I love these so much is because all of these questions have the exact same format. Okay, what we're going to do is first of all work out the auxiliary equation. So I'm going to shorten it to AE. Okay, so we're going to work out the AE first of all. Basically, it's factorising. Alright, and if you can factorise, it's an easy mark. Okay, then that leads us to three cases, which you can see at the bottom here. Okay, so I'm going to be doing 3 questions, one of each of these, and then after that I'll put up a summary page, which basically is your rules for all that we're going to solve. Okay, so if you've not done so already, pause the screen at this point, copy this page into your notes jotter, then we're going to start our first example. Okay, so write in here examples. These questions are usually worth between 7 and 10 marks in an exam, so they are worth a lot of marks for each of them. And it's the exact same format you're following for every single one, and that's why they're so good. Okay, so number 1, find the general solution. Oops, that's for general. Here. Find the general solution, and your second order differential equation is d squared y by dx squared minus 4 dy by dx plus 3y equals 0. Okay, so all of our second order differential equations right now are going to be equal 0. Okay, and then once we've done a couple of these, later on, like next week or something, we'll change this 0 to a number or something and just make it a little bit harder. But right now we're focusing on when it equals 0. So these are the slightly easier ones. Okay, so for your answer, what we're going to do is we're going to work out the AE first of all, the auxiliary equation. I really struggle to say that word. So the AE, right, so right at the side here. So auxiliary equation. Okay, so you don't need to label it. You're getting 0 marks for this point. This is just to show you what we're doing. I'll shorten it to AE. Alright. Basically, you're looking at the left hand side. Okay, and we are picking off the coefficients from here. And we use the letter M for this, and I don't know why we do the letter M, it just is. Okay, so here we're changing the d squared y by dx squared by m squared. Then you've got minus 4, and we're going to change that to m. And then here you're just left with plus 3. So it's not plus 3y, it's just plus 3. So we're kind of setting up like a trinomial like this, using the letter m and the coefficients from each of them, and then no matter what, this always equals 0. Okay, I'm just writing here. This always equals 0. Okay, so even if you've got like a number or a sign x on this side, this always equals 0. Okay, then what we're just going to do is just going to factorise. So does this factorise nicely? That's your next question. So what times what gives you 3? It's just 3 and 1. Can you make minus 4 from that? Yes, you can. So you get m take 3, m take 1 equals 0, which obviously if you solve for m, that gives you 3 and 1. Okay, so this is going to be the first type of the second order differential equation that we could get. This actually gets you 1 mark just for factorising and equating it equal to 0. So then what we're going to do is we are going to then work out the general solution. So general solution, just call this GS. Remember, you don't need these wee headings at the side here. That's just for my benefit. Right, so the first type of first order differential equation is when you've just got two nice values for m and they're different. So we've got 3 and 1, they're nice numbers, they're different, they're linear, happy days. So our general solution is going to be of the form y equals capital A e to the power of, so we take the first number, which is a 3, that's going to the power of 3x, plus capital B e to the power of the next one is 1, so it's 1x. So I'll just change it for an x in there. And that's us done. Okay, that's the general solution. And so a and b are obviously just constants. Then e to the power of, and we just take each one of these and we just make that as a power. Okay, so I'll put all this up in my summary page at the very end. This is what you do when you get two nice numbers from your AE. Just like this. Right, question 2. It is going to look very similar. So find the general solution of, right, so you've got your second derivative, d squared y by dx squared minus 4 dy by dx plus 4y equals 0. Okay, so this looks very similar to the one before, right? So I'm just going to flash back a page so you can see the difference. Okay, there is no difference pretty much. Okay, you've still got a second order differential equation. The first thing we're going to do is the exact same. We're going to work out the AE first of all. So it's just taking the coefficients of the left hand side. So here, this just gives us m squared. Here I've got minus 4. So that's going to be minus 4m. And then at the end you just get plus 4. Always equals 0 like this. Okay? And you always just try to set up a trinomial and then factorise. So have a wee think. Does this factorise nicely? So what times what gives you 4? 2 and 2. Can you make minus 4 from that? Yes, you can. So you get m take 2, m take 2 in your brackets. Factorises really nicely. So if you equate both of them equal to 0, that's just going to give you m equals 2. Then I'm just going to put in brackets twice, because you get m equals 2 from this one, and you also got m equals 2 from this one. Now can you see why this one is different from the one before? So if I go back a page, when we factorise we get two nice numbers for m, 3 and 1, they're different. This is the second type. This is a repeated type when you get two numbers and it changes your general solution, and you just need to remember what happens pretty much. So it's very similar. So you're going to do y equals a e to 2x, right? Very similar to the one before, capital A e to 2x plus. Now because I've got another 2x in here, I don't want to write a b e to the 2x, because then that's pretty much just the exact same as this one. So what we're going to do is we're just going to fire in a wee x term here, but still do the b e to the 2x, but just multiply that by x there, right? You just need to remember these. Okay, so that's what we do when we've got a repeated term. You still do a e to 2x blah blah blah, but you stick a wee x in there. Okay, right. Third example, and then I'll put up a summary page of what to do in each situation. Okay, so number 3, find the general solution of okay, so your second derivative is dx. So d squared y by dx squared plus 2 dy by dx plus 5y equals 0. Okay, so this looks the exact same as questions 1 and question 2. Okay, we're going to start it the exact same way as you will do for any second order differential equation. We're going to start with our AE first of all. Okay, so you know the drill by now, hopefully. This gives you m squared. Middle here you've got plus 2, so it's plus 2m, and at the end you've got plus 5. This always equals 0. Okay, then your next step, can this be factorised nicely? So the last number is a 5 here, so So the numbers that multiply to give you 5 are 5 and 1. Can you make 2 from this? No, you can't. Okay, so this is the third type when it does not factorise nicely. Just going to put a wee note in here saying I can't factorise. So if you cannot factorise something, what we're going to do is we're going to use the quadratic formula, which you're expected to remember that formula off by heart. Yep, so use the quadratic formula. So the way that I like to do this is I like to write A, B, C at the side here. So A equals, B equals, and C equals. So I've got 1, 2, and 5. Then we'll do our formula. So normally it's X equals whatever, but in this case it's going to be M equals. Formula, I just need to remember, so minus B plus or minus the square root of B squared minus 4AC all over 2A. If you want, feel free to pause the video at this point and try this by yourself. So I'm just going to go through it quite slowly. So minus b at the front, so this gives us minus 2 plus or minus b squared. So b is 2, so 4 squared is, sorry that's the answer, 2 squared is 4. Take away, you've got 4 times a times c. A and c are 1 and 5, so 4 times 1 times 5 just gives you 20. So I'm doing a little bit of working in my head. All over 2a, a is 1, 2 times 1 is 2. Let's get it simplified. So this gives you minus 2 plus or minus the square root. 4 take away 20 gives you minus 16 all over 2. Now what would normally happen in higher maths is that if you get a negative under the square root sign, that should ring alarm bells. However, we have done the topic of complex numbers and this is allowed. Okay, we can just pull that negative sign out the front and that just becomes I. Then the square root of 16 just gives you 4. So this is just minus 2 plus or minus, that just gives you 4I in that case. All over 2, and then if we just divide everything by 2, that just gives me minus 1 plus or minus 4 divided by 2 gives me 2I. Okay, so I've got my real number there, minus 1, then I've got my complex number, which is going to be 2. Right, so this is the third type of second order differential equation when you end up with complex roots. Okay, so what you do in that case is your general solution looks very different from the two before. Okay, and it's just going to be e to the power of, now you take the real root here, so it's minus 1. So here it's going to be minus 1x. So I'll just shorten that to minus x. Open bracket. So a cos, I'm going to keep these blank, plus b sine, keep that blank. Okay, so you just get a and b, then you get cos and then sine, it doesn't matter what order they go in. And then see what goes in the brackets here, is you take the imaginary part, which is 2, so it's just going to be 2x for both of them. It doesn't matter what cos or sine comes first. So that's what you do if you end up with complex roots. So the real part goes with your power, so e to the minus x. And then the imaginary parts go inside the brackets. Okay, so I've kind of done things a little bit backwards today. I've done the examples before I give you the notes as such. Okay, so here is your summary page. Now, first of all, I've just taken this directly from the textbook, which I know you guys don't have yet, which is why I've just copied it on here. So you can freeze or pause this video at this point and copy this in. It's basically saying that step 1, write down the auxiliary equation, which is what we did. Solve it by factorising, which is what we did. And then the key parts here, I think, are those 3 at the bottom. Right, it's basically just everything that I went through. So if you end up factorising, you get 2 nice roots, M1, M2, that's just like your 3 and the 1 that we had before. Then if you end up factorising, you get the same number, like 2 and 2, which we did. You just need to fire in a wee x in the middle there. And then if you end up factorising, you find out you can't factorise, so you do the quadratic formula. It just gives you this. So So the power for the exponential, that's just your real part, and then the q, that's just like their imaginary part in there. Okay, so feel free to copy down these notes, or I've got other notes here that you can copy down. So this is going to be your Bible pretty much for when you're solving your second order differential equations. Okay, so get this copied in somewhere, that's your summary, and then I'll put up the questions for this lesson. Okay, so here are the questions. Quite a lot of questions, but they are quite short. Okay, so for each of these, I want you to write them down. Then write down the AE. Okay, so that's when you do like m squared minus minus 6 equals 0. Factorise, and then see if it falls in to like which category 1, 2, or 3. When you've got two nice roots, when you've got a repeated root, or if you've got complex numbers. Okay, and I'll stick the answers up now. So these are what your answers should look like. Okay, if you're struggling with anything at all, then please let me know. Okay, because these are the basic questions, and we're going to be using this and building on more and more stuff when we do the more advanced stuff.